What's going on, guys? You're here with Jono for another quick math lesson. Today we're going to look at the introduction to indices. What are they? What do they represent? And how did mathematicians get away with being lazy once again? So when we're talking about indices, we're talking about those small little numbers that sit on top of the shoulder of a big base. So these small numbers are written as a superscript up the top. But before we look at that, we're going to have a throwback to what multiplication actually means. So multiplication is a shortcut for addition. So in this example here, we've got 6 plus 6 plus 6, which is equal to 18. But another way of saying this is that we have this number 6 and we have it 3 times. So instead of 6 plus 6 plus 6, we've got 6 3 different times. So we can write 6 times 3, which equals the exact same thing. So with that in mind, indices are just a shortcut to saying that we've got groups of multiplication. The only important thing here is that they are multiplication of the same number. So in this example here, we've got 3 times 3. We've got this 3, and because we have 3 times 3 twice, we write a little 2 up the top. And what this says is that the base here, the base is multiplied by itself this many times. And this is all the information that an indice communicates. So to go the other way, if we've got 4 to the power of 5, that means that we've got 4 times, okay, 4 times, and we have this notation 5 more times. So we're saying that the base 4 there is multiplied by itself 5 times. In these types of questions, you don't have to solve the question. We're just asking, what is this representing? 4 to the power of 5, what does that mean in terms of multiplication? So we do have 2 types of questions. The first one is taking expanded forms, or the multiplications written out in like a lot of detail. What does that look like in an indice? So it'll ask you to write it in index form. You have to be really careful. Don't just type this into your calculator. The question's not asking you to solve it. What it is asking you is how many times does the big number multiply by itself? So these are really cruisy to get quick marks really effectively. So if I have 4 times 4 times 4, the base of my indice is that big number. So that doesn't change. So this is equal to 4, and we've got it timesing by itself 3 times. So the index, or the little thing on its shoulder, is just 3. And that's all you've got to do. You don't have to solve it. You don't have to put it in your calculator. That's the answer. Pretty cruisy. In another example, if we've got these 7 timeses, we have 7 multiplied by itself 5 times. So the base is the big number, and then the number of multiplications is up the top. This can also happen if we've got algebraic letters. So if we've got y multiplied by itself 4 times, this is just equal to y, which is the base, to the power of 4. The other type of questions we could get is we're given an indice and we have to explain what it represents with multiplication. So it's going the other way. Again, we're not trying to solve this in our calculator. If the question asks you to solve, then you have to put it in your calculator and get a final answer. This is just saying, hey, what is this trying to communicate? So for this one, because the base is 2, I've got 2 times, that's my big number. And then because it's to the power of 4, I have to write this out 4 extra times. So this becomes 2 times 2 times 2. 2, the base, is multiplied by itself 4 times. So that's all you have to write out. This next one, 6 to the power of 5. 6 is the big number, multiplied by itself 5 times. And that is all we have to do. Finally, this happens again with algebraic terms. If you've got b to the power of 3, just because it's a letter doesn't mean we change anything. All this is saying is that we have b multiplied by itself 3 times. Thanks so much, and I'll see you later.